All right, let's throw in a new arithmetic move to our toolkit now, and that is exponentiation, which just means using exponents. Exponents mean you multiply a number by itself a bunch of times. These expressions come up a lot in algebra, especially squaring. Squaring just means multiplying a number by itself. But if you had to multiply a number by itself like 3, 4, 5, 6 times, you wouldn't want to write all that out, so we just have a shorthand. This is just one example, but instead of saying or writing 2 times 2 times 2 times 2 times 2, we can just say or write 2 to the 5th, or 2 to the power of 5. And the 5 goes in a little superscript above the 2. You've probably seen that before, but that's an exponent. So in general, you can have any number to any exponent, but for now, exponents are going to be positive whole numbers, like 5 or 2 or 6. But in general, if you have a number to the n, that just means a times a times a times a dot dot dot, and there's n total factors in there. So there could be 100 factors, right? You would never want to write that out, but you don't have to anymore because you can just put a little exponent of 100. All right, a is called the base for vocabulary, and n is called the exponent. So in 2 to the 5th, 2 is the base, 5 is the exponent. For example, to do something like 4/3 to the 5th. Now, in general, like you wouldn't really want to do this by hand, especially if I gave you 4/3 to the 10th or something. I would never make you multiply 4 by itself 10 times. You could technically do it, it would just be super tedious. So for some of this stuff, we are probably going to use a calculator, and then just trust that the stuff on the exam you won't need a calculator for. But just to see what this looks like, this is just 4/3 times itself, a total of 5 times. I should say a total of 5 factors in there. It's really times itself 4 times, but whatever. A total of 5 factors of 4/3. And then notice, when you multiply fractions, you go across the top and you go across the bottom. So with fractions, you'll notice this does just turn into 4 to the 5th over 3 to the 5th. But then, like I said, your calculator can tell you what 4 times 4 times 4 times 4 times 4 is. It's 1024. And then 3 times itself 5 times is 243. And then you know that you can't actually simplify that anymore because you don't see any common factors in the factorization up here and the factorization down here. So that's it. You're done. Here's one thing we want to be clear right away with negatives, and this sort of refers to order of operations, which is the very next thing I'm going to talk about. So these two expressions, you might think, well, isn't that the same thing? No. And here's why. So if you look at the first one, the base is actually -3. Because of the parentheses, it's the -3 that's being exponentiated. So that first expression is -3 times -3 times -3 times -3, which is 81. Notice every time you multiply another negative, the sign kind of flips back and forth, so it comes out to be positive. So in this second expression, the base is actually 3, and the negative is acting on the whole thing. So it's that. So you see the difference? You do so because of the parentheses, you do 3 times 3 times 3 times 3 first, which is 81, and then the negative acts on that. So that expression actually gives you -81. Okay, so you have to be careful with negatives when you're doing these things. And again, the next thing we'll talk about order of operations. You just have a very clear sort of strategy for what exactly you should do first when you see something like that. And here we go. So if you've heard the phrase PEMDAS before, I know that's not a word, but that's what we're doing right now. It's just an acronym for which things to do first when you see an algebraic expression. And we want to talk about why. This isn't like just because. There's a good reason why we do things in the order that we do. So if you look at something simple like 2 times 6 plus 7. If we did the 6 plus 7 first, we'd get 6 plus 7 is 13, and 2 times 13 is 26. If we did the 2 times 6 first, we'd get 2 times 6 is 12, and 12 plus 7 is 19. So obviously, one of those has to be right. We can't just have half the class saying that it's 26 and half the class saying that it's 19 and say, well, agree to disagree. No, this is math. There's no disagreement allowed. It's one or the other. So it is, you may know, it's the second thing. You do the 2 times 6 first. And that's not because you're just going from left to right. That's because you actually always multiply first. And let me show you why. So multiplication is like short for addition. So 2 times 6 really does mean 2 plus 2 plus 2 plus 2 plus 2 plus 2. So if you wrote it out like that, you'd notice that that expression really means 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 7. Which is 19, right? Which is 12 plus 7, which is 19. So because that's how we define multiplication, that's why that's correct. That's why the actual answer is 19. So it's not 26. It's not open to interpretation. The answer is for sure 19. So that's the first big rule. Always multiply before adding. Regardless of the order, it doesn't matter. So you go through the whole thing, you say, okay, here we got multiplication here, here, and there. We're going to do that first. Okay, so now we're going to sort of expand that and extrapolate that to say we actually multiply and divide everything before we do any addition and subtraction, because those things are kind of always grouped together. Okay, so division is the same thing as multiplying by the reciprocal, and subtraction is the same thing as adding like the negative version. So for that reason, what we just said, always multiply before adding, we can just expand that to say always multiply and divide first before you do any of your adding and subtracting. Okay, so let's do a couple examples. I want to do plenty of examples here. So in this expression, it might, if you just went from left to right, you'd go 86 minus 4 first and get 82, but that's wrong. That would give you the wrong answer. Instead, you just look for multiplication, so 4 times 3. So you do that first. So you do that, and then this turns into 86 minus 12 plus 6. And now you know we've seen this kind of thing. This is the problem. It's just addition and subtraction. So now you just go from left to right. And even if you didn't go from left to right now, you'd get the same answer, but whatever. Just go from left to right because it's simplest. So 86 minus 12 is 74. 74 plus 6 is 80. Like that. Okay, so there's only one answer here, and it's 80. What parentheses do is they kind of, if you ever did need to, let's say, add some numbers first and then multiply something, you could just put parentheses around the stuff you wanted to happen first. So what parentheses mean is do this first. So if there's anything in parentheses or braces or brackets, we can have different kinds of parentheses mixed in. You always want to do that first. Like that. So if the parentheses weren't there, this is good. If the parentheses weren't there, you would do that 9 times 5 first. But they are. So you do whatever, you deal with whatever's inside the parentheses. Essentially, you get rid of the parentheses first. So 2 minus 9 is negative 7. And 5 plus 4 is 9. So this really is negative 7 times 9. Okay? And once you've evaluated the expression in parentheses, you don't need them anymore. You could still have them here, but they don't do anything, right? So negative 7 times 9 is negative 63. All right, if you removed the parentheses from that problem and did it, you would have a much different result. If your expression has a division bar, you deal with the numerator and you deal with the denominator first. So you basically treat them as if they were in parentheses of their own. Like that. And really, I mean, there's really no other way to do it. I just wanted to make sure we, did one like this. So again, I'm getting lazy and using the little asterisk symbol instead of the dot for the times symbol, but you know what that means. So this is 9 times 3 over 5 plus 11 times 2. So you can kind of like, you don't just need to do one thing at the same time. So you know that we're going to go and do all the multiplication first. So 9 times 3 is 27. And then in the denominator, 11 times 2 is 22. Right, so it's like we're obeying order of operations within the denominator. Okay, and then we do 5 plus 22, which is 27. And then finally we simplify, and 27 over 27 is just 1. So the instructions here, when I say evaluate, I could say simplify the expression, and I would really mean the same thing. Just get it as simple as you can. And obviously 1 is, you can't get any simpler than that. So if we have more than one type of parenthesis, or one, I should say, grouping symbol, braces are a different thing. Or I'm sorry, those are brackets. Braces are the flowery brackets. So you start in and you work out. So you start with the innermost bracket or parenthesis or whatever it is, and then you move outwards like this. Okay, so a little bit more going on here. We have in brackets 5 plus, in parentheses, 3/4 times -8, and then outside a times 2. So if you see something like this, you know, this doesn't mean 3/4 minus 8. This means if we meant that, we would just not put the parentheses. This means 3/4 times -8. So when you put two things right next to each other, that means times. It's like multiplication is so common that at some point you just, like if you write 5x, that means 5 times x. This is the same thing. Okay, and then same with the 2 that's just sitting out here. If there's no operator here, like a plus symbol, it means times. Okay, so here we go. So the parentheses are inside of the brackets. So we do the parentheses first. So for the very first thing we do is 3/4 times -8. 3/4 times -8 is -24/4. Now, if you wanted to simplify that first and say, okay, we could take a 4 out of the -8 and say that that's the same as 3 times -2, great. I wouldn't fault you for that. You're just going to get to the -6 that we're getting to right now. There you go. So that's 5 minus 6, or 5 plus -6. So again, we're kind of doing more than one step at once because we're good at this. So it's 5 plus -6, or 5 minus 6 times 2. Now we deal with the brackets. 5 minus 6 is -1. And now we kind of need a multiplication symbol, because if I just wrote -1, 2, that would look like -12. Okay, so -1 times 2 is -2. All right, so you should all get the same answer for these. Like I said, this stuff isn't open for interpretation. All right, let's throw exponents into the mix. 3 times 5 squared really means 3 times 5 times 5. So 3 times 5 times 5, you just go, left to right and multiply. So 3 times 5 is 15. 15 times 5 is 75. But what you wouldn't do is you wouldn't do the 3 times 5 first and then square that. Okay, so what I'm trying to say is exponents come first. All right, so we said multiply before adding, but now we have something that even comes before multiplying, and that's exponentiation. The example. So there will definitely be a lot like this one on the test. And I do need to see your steps. So 3 times 4 squared minus 10 over 2 times parentheses 2 minus 11. So again, you don't have to do just one step at a time. So in the numerator, you're going to do the 4 squared before you do anything else. So 4 squared is 16. So that's going to be 3 times 16 minus 10. And then in the denominator, in the same step, you can go ahead and do 2 times 11. So the denominator is going to be 2 times -9. All right, and then in the numerator, you do the multiplication first. 3 times 16 is 48. And then if you want, at the same time, you can go ahead and tell me that 2 times -9 is -18. Why not? All right, so finally, let's see, we have 48 minus 10 over negative 18. Now just finish the numerator. 48 minus 10 is 38. And we know that a positive divided by a negative is negative. So we can simplify. So always remember, we want to simplify every single one of our answers. So it's not quite there yet, right? This isn't like really the wrong answer, but you would get a point off for not simplifying. So just divide the top and the bottom by 2. 38 divided by 2 is 19. So it's going to be 19 over negative 9, which is the same exact thing as saying negative 19 over 9. This is the way I would like you to put it. If you left the negative in the denominator, I wouldn't mark it wrong. But since you asked, this is good. So do this. Leave it like this. In other words, you see it's subtle, but instead of the negative being down here, the negative is out front. It just indicates that the whole thing is a negative number. So the answer is negative 19/9. Okay? All right, let's sum it up. Parentheses come first. Starting with the innermost parentheses or brackets or whatever's innermost and working out. And then within that, you do exponents first. Then you do any of your multiplication and division you have from left to right. And then you do any addition and subtraction you have from left to right. Okay? So your book doesn't have this goofy acronym, but it's what I've always known forever, and it's PEMDAS. So it's not even a word. Parentheses, exponents, multiplication, division, addition, subtraction. That word. So if that helps you, acronyms help people. So just PEMDAS. If you've ever heard somebody say, please excuse my dear Aunt Sally, I don't know why that's the mnemonic device that people use, but it just is, and it doesn't matter if it's dumb. If it helps you remember it, then it does what it's supposed to do, okay? Please excuse my dear Aunt Sally. Now, multiplication and division are grouped together, as is addition and subtraction, so I'm going to be a little finicky and say that it really should be that. It's like PEMDAS, because multiplication and division happen at the same time, and so do addition and subtraction, but it wouldn't really matter if you just did it like PEMDAS, okay? So you do have to memorize that order of operations. And you will have to forever. That never goes away. It'll be calculus 3 and you'll be doing order of operations. So this is not something that's ever going to change. Well, let's do one last example that just has a bunch of stuff all thrown in, because this really combines everything we've done thus far, doesn't it? Right? Okay, so we have in brackets 9/10 divided by 2/5 plus 1/5 plus 7/2, and then all of that times 1/10. So you start with the parentheses, right? Because they're inside. 2/5 plus 1/5 is 3/5. All right, so we have 9/10 divided by 3/5 plus 7/2, all that times 1/10. Then let's see, we're still inside the bracket, so first we do the division before the addition, right? So 9/10 divided by 3/5 is 9/10 times 5/3. All right. Now you can do the little slash thingy before you multiply. That's what I would do. I'm not going to write it, but you could take a 3 out of the 9 and the 3, and you could take a 5 out of the 5 and the 10, or you could just go for it and get 45 over 30, and you'd eventually discover that's the same as 3/2. So whichever path takes you on that journey there. 9/10 times 5/3 is 3/2. So now we have 3/2 plus 7/2, but that's inside the brackets. So if those weren't there, we'd do the multiplication first, but they are. So we do the addition first. 3/2 plus 7/2 is 10/2, which is 5. So I just went ahead. Sometimes I get a little lazy. 3/2 plus 7/2 is 10/2, and 10 divided by 2 is 5. So I just jumped right there. 3/2 plus 7/2 is 5. Finally, 5 times 1/10 is 5/10, which is pretty easy to jump to the fact that that's 1/2. There you go. So that whole thing boils all the way down to 1/2. And you'll know when you're done, right? If you stopped at 5/10, like I said, you'll get a point off because you're not all the way there. Okay, this isn't really even a story problem, it's an application. So this is how annual interest works. It's pretty simple. If 5,000 bucks is invested at 4.5% annual interest, and you let that sit there for 5 years, right? Don't touch it. The amount you're going to have at the end is given by 5,000 times parentheses 1 plus 0.045 to the fifth. No, I can't, well, I'm not going to totally explain that formula now, but it's true, it's real. I think you know where the 0.045 comes from. That's what 4.5% is as a decimal. And all I want you to do is find this amount. So you're gonna use your calculator for this. So for that reason, like, this won't be on this test. But I want you to know where these buttons are in your calculator, so figure it out. But order of operations wise, first you do the 1 plus 0.045. And that's just 1.045. That's literally what that means. So, right, I would never ask you to do 1.045 to the fifth by hand. You'd have to multiply by itself 5 times. Ugh. And what you get is going to have a lot of decimal digits, and that's fine. So go ahead and punch that into your calculator. I'm going to have to use the approximately symbol because I don't want to write out all these digits. I think you've seen that symbol before. It means meh, about, right? It just means when you round something, when you don't want to write all the digits because it's impractical. So that's about 5,000 times 1.24618. And then obviously, again, you could do that by hand, but don't. Just punch it into a calculator. Turns out to be about 6230.9. And then for a problem like this in application, I want to see units and I want to see proper rounding. And with money, it's nice because the proper rounding, it's like it's already built in. You round money to, well, think about it. How many decimal places do you round money to? I shouldn't have to tell you. You round money to 5 decimal places? No, 2 decimal places, because that's cents. So I'm not going to tell you that, but you should do it. Okay, so like the answer as we have it isn't really right. The answer has a little dollar sign in it, and it's 6,230.90 cents. Like that, right? That's the proper answer. Okay, thank you.